Coming up on SpaceTime, the ancient Martian mud cracks that could have sparked life on the red planet. Europe's Eucalyptus spacecraft reaches its final orbit, and a fiery space junk display in the skies high above Melbourne. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists say the discovery of mud cracks on the red planet's surface by NASA's Mars Curiosity rover suggests that this area may have been favourable for the emergence of microscopic life on Mars if it ever existed there. Scientists, of course, aren't entirely sure how life began here on Earth. But one hypothesis suggests that persistent cycles of wet and dry conditions on land helped assemble the complex chemical building blocks necessary for microbial life to evolve. And that's why a patchwork of well-preserved ancient mud cracks found by Curiosity is causing so much excitement for mission managers. The discovery, reported in the journal Nature, details how the distinctive hexagonal pattern in these mud cracks offers the first evidence of wet-dry cycles occurring on early Mars. The study's lead author, William Rapin from France's Research Institute of Astrophysics and Planetology, says this type of mud crack forms when wet and dry cycles occur repeatedly, perhaps seasonally. The robotic mobile laboratory first spotted the mud cracks back in 2021 after drilling a sample from a rock target named Pontours, which was found within a transitional zone between a clay-rich layer and one higher up that's enriched with salty minerals called sulfates. While clay minerals usually form in water, sulfates tend to form as water evaporates. The minerals prevalent in each area reflect different eras of Gale crater's history. The transitional zone between them offers a record of a period when long dry spells became prevalent and the lakes and rivers that once filled the crater began to recede. As mud dries out, it shrinks and fractures into T-shaped junctions. These are what Curiosity discovered previously at the old Soka site, a collection of mud cracks lower down on Mount Sharp. Those junctions are evidence that old Soka's mud formed and dried out once, while the recurring exposures to water that created the Pontours mud caused the T-shaped junctions to soften and become Y-shaped, eventually forming a hexagonal pattern. The hexagonal cracks in the transitional zone kept forming, even as new sediment was deposited, indicating that the wet-dry conditions continued over a long period of time. KenCam, Curiosity's precision laser instrument, then confirmed a hardy crust of sulfates along the crack's edges, which isn't too surprising given the proximity to the sulfate region. The salty crust is what made the mud cracks resistant to erosion, preserving them for billions of years. Rapin says it's the first tangible evidence that the ancient Martian climate had regular Earth-like wet-dry cycles. But even more important, these wet-dry cycles are helpful, maybe even required, for the molecular evolution that could ultimately lead to life. Although water is essential for life as we know it, a careful balance is needed. Not too much water, not too little. The kinds of conditions that sustain microbial life, those that allow a long-lasting lake for example, aren't the same as the conditions scientists think are required to promote the chemical reactions that could lead to life. A key product to those chemical reactions are long chains of carbon-based molecules called polymers, including nucleic acids, molecules considered to be the chemical building blocks of proteins, which are essential for life as we know it. And wet-dry cycles control the concentration of chemicals that feed those fundamental reactions, leading to the formation of polymers. Over its 11 years on the surface of the red planet, Curiosity has found ample evidence that ancient Mars could have supported microbial life. Now, the mission has found evidence of the sort of conditions that may well have promoted the origin of life as well. The discovery of the Pontours mud cracks may well have provided scientists with their first opportunity to study the remains of life's cauldron. Remember, Earth's tectonic plate activity constantly recycles its surface, thereby bearing examples of prebiotic life on this planet. Mars doesn't have tectonic plates. So, much older period of that planet's history have been preserved for scientists to study. And who knows what they'll find. This is SpaceTime. Still to come, ESA's Eucalyptus mission reaches its final orbit, and Victorians treated to a fiery sky display as space junk plummets towards the surface. All that and more still to come on SpaceTime. The European Space Agency's Euclid spacecraft has finally reached its final orbital perch, a gravitational well some 1.6 million kilometres away on the dark side of the Earth, known as the Lagrangian L2 position. There it joins the James Webb Space Telescope in a halo orbit, searching the distant universe with infrared eyes. Euclid's mission was launched aboard a Falcon 9 rocket from the Kennedy Space Center in Florida over a month ago. Unlike Webb, which is hunting for the earliest stars and galaxies, Euclid is undertaking a deep sky survey, searching for the effects of dark matter and dark energy by accurately measuring the accelerating expansion of the universe itself. To achieve this, the telescope will measure the shapes of galaxies at varying distances from Earth, and it will investigate the relationship between distance and redshift, that is, how much the universe has been stretched by the physical expansion of space-time. Dark matter is a mysterious invisible substance that makes up over 80% of the total mass of the universe. Scientists are pretty sure it exists because they can see its gravitational interaction with normal matter, preventing galaxies from flying apart as they rotate. On the other hand, dark energy is causing the expansion of the universe to accelerate. So studying it will help astronomers determine the ultimate fate of the universe, and consequently us. Named after the ancient Greek mathematician Euclid, the mission advances and complements ESA's Planck telescope, which operated between 2009 and 2013. Its wide-angle telescope is equipped with a 600-megapixel camera to record visible light, a near-infrared spectrometer, and a photometer to determine the redshift of detected galaxies. Euclid will develop a three-dimensional map of the universe containing a vast amount of data. In fact, it will cover more than a third of the sky, and its third dimension will represent time spanning some 10 billion years of cosmic history. But dealing with that huge and detailed set of novel data that Euclid's observations will produce won't be an easy task. To prepare for it, scientists with the Euclid Consortium have developed one of the most accurate and comprehensive computer simulations of the large-scale structure of the universe ever produced. They've named this the Euclid Flagship Simulation. Running on large banks of advanced processors, computer simulations provide a unique laboratory to model the formation and evolution of large-scale structures in the universe, things like galaxies, galaxy clusters, and the filamentary cosmic webs they form. These state-of-the-art computational techniques allow astronomers and astrophysicists to trace the motion and behavior of an extremely large number of dark matter particles over cosmological volumes under the influence of their own gravitational pull. They replicate how and where galaxies form and grow, and can be used to predict their distribution across the celestial sphere. This report from ESA TV.
In the past 20 years, cosmology has undergone a transition towards precision science. The standard cosmological model has been established, and its parameters are being measured with accuracy. Euclid will improve this model's precision and help us unveil the dark universe by studying the large-scale distribution of galaxies and cosmic structures. At 1.5 million kilometers from Earth, we witness the stars in the Milky Way, our galaxy, observed by Gaia. Euclid will impose highly stringent constraints on the cosmological model that governs our universe. Euclid will generate images in the visible and infrared, covering 1/3 of the sky. We have created the largest and most comprehensive virtual galaxy catalog to date. Our simulated universe, simulated dark matter distribution, is not randomly distributed, but rather forms clusters, filaments, and voids in between. Galaxies are tracers of the dark matter distribution. There are different types of galaxies. Euclid's flagship simulation allows us to visualize the universe from different points of view, giving us a better understanding of the evolution of the formation of structure in our universe over time. Euclid will explore even further than our simulated universe. We have observed the universe from Earth, from space. Euclid's flagship simulation brings the dark universe to life, blending observations with our best theoretical model of the dark universe. Join Euclid on this extraordinary journey to unlock the mysteries of the universe.
This is SpaceTime. Still to come, a fiery display of space junk in the skies above Melbourne, and later in the science report, a new study suggests that Europe's first human inhabitants were all wiped out by a mass glaciation event. All that and more still to come on SpaceTime. Melbourne residents looked skywards in amazement last week when a series of bright orange fireballs came streaking out of the northern sky. There were thousands of reports across Victoria and Tasmania of a bright light streaking across the evening sky, leaving a fiery trail in its wake. ASA, the Australian Space Agency, said the spectacular nighttime display was space junk, the breakup of a Russian Soyuz 2 rocket that had been launched earlier in the evening from the Plesetsk Cosmodrome 800 kilometres north of Moscow. The mission was carrying a new generation of GLONASS K-2 global navigation satellites into orbit for the Russian military. The sped-up stage, which was travelling at some 7 kilometres per second, was seen to break apart as it fell, with huge segments being torn off the main fuselage as it plummeted through the atmosphere. The remains eventually hit the planet's surface in the Great Southern Ocean, southeast of Tasmania. A NOTAM, or Notice to Airmen warning of the event, had been issued the previous day. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. Long before Homo sapiens ventured out of Africa and arrived in Eurasia, an earlier hominid species, Homo erectus, had already paved the way. Homo erectus spread out of Africa over 1 million years before Homo sapiens. Fossils of Homo erectus show they spread east through Eurasia into China as Peking man and then south into Indonesia as Java man. But they also travelled north and west into Europe, where bands of early Homo erectus hunter-gatherers colonised the land, making innovations in stone tools as they spread, thrived, and eventually died. But new evidence suggests the hominid occupation of Europe wasn't continuous. A report of the journal Science claims a massive North Atlantic cooling event during the Pleistocene epoch about 1.1 million years ago, and lasting some 4,000 years, appears to have been so frigid it wiped out Europe's entire Homo erectus population. An examination of the hominid fossil record and stone tool evidence in Europe suggests a gap in human occupation of about 200,000 years, starting some 1.1 billion years ago. The authors reconstructed the ancient climate using organic sediments left by algae and pollen in deep-sea core samples, which showed temperature and vegetation changes over the years as average temperatures plummeted by 4.5 degrees Celsius. This extreme glaciation deprived Homo erectus of food resources, resulting in a complete interruption of early hominid occupation of Europe. In fact, it wasn't until some 900,000 years ago that more resilient hominids in the form of Neanderthals arrived. As for modern-day humans, Homo sapiens, they began showing up in the fossil record in Africa around 300,000 years ago, and may even have briefly appeared in Europe more than 200,000 years ago. However, Homo sapiens' main push out of Africa didn't happen until 65,000 years ago, eventually replacing Neanderthals in Europe around 40,000 years ago. A new study warns that weather and climate change impacts are increasing in Asia, which is now ricocheting between droughts and floods, ruining lives and destroying livelihoods. There were 81 weather, climate and water-related disasters in Asia in 2022, of which over 83% were flood and storm events. And a new report by the World Meteorological Organization warns that melting ice and glaciers, together with rising sea levels, threatens more socio-economic disruption in the future. The report found that more than 5,000 people lost their lives and more than 50 million people were directly affected by the weather-related events of 2022. It also found more than $36 billion in economic damages due to climate change events in Asia. A new study shows that adults over 60 who live unhealthy lifestyles are more than twice as likely to be admitted to a nursing home early. The findings, presented at the International Congress on Obesity in Melbourne, was based on a study of over 100,000 people over the age of 60 in New South Wales over a period of 10 years. They found that 18% were admitted to a nursing home during that time. The authors then looked at the lifestyles of the participants and categorised them as high, medium or low risk lifestyle based on factors like smoking, exercise and diet. They say compared to those in the low risk group, the risk of a nursing home admission was 43% higher in the high risk group and 12% higher in the medium risk group. And smokers had a 55% higher risk than non-smokers. In the immortal words of Dr. Sheldon Cooper,
I don't mean to be rude or discourteous, but before we begin, I'd just like to say that there's absolutely no scientific evidence to support clairvoyance of any kind. Which means, and again, no insult intended, that you're a fraud, your profession is a swindle, and your livelihood is dependent on the gullibility of stupid people.
Never get tired of hearing that, although I'm sure psychics do. Well, it now seems psychics are trying to broaden their scope by moving into new areas of the paranormal world and delving into the ancient Chinese practice of Feng Shui. Tim Mendham from Australian Skeptics says, at least by focusing on Feng Shui, they're keeping in the spirit of things.
There's a story recently that came out with a psychic who was advising on Feng Shui. And Feng Shui is the Chinese practice of making sure your house is laid out and aligned properly to maximise your luck, etc., your good fortune, and you're trying to avoid things.
Or something, isn't it?
Yeah, you shouldn't have a back door opposite a front door because the good luck comes in and goes straight out again. Various things are how you align stuff anyway, your garden, everything, your furniture.
The idea of having a little closet just to keep the bad spirits in.
Yes, a little closet to keep the bad spirits in. So you put them away with the old clothes and the mothballs. This story suggests that the unluckiest items to have in your home, and number one is lilac. Apparently lilac is an old tradition, they say, that forbids lilacs in the house. They link lilacs with fairies and bad spirits, and inviting the spirits and fairies into your home is not such a good idea. Outside the house is fine, you can have as much lilac as you like. Now, it's also suggesting that lilac blossom was used to cover up the smell of illness and death. That might be the case, I don't know. But anyway, so don't have lilac in your house. If you're going to have cacti in your house, put them by the front window because that will scare off bad energies. You shouldn't have cacti in the house because the thorns represent bad luck and represent sort of something negative. You have them outside again, that's fine. But if you're going to have them inside, put them near a window. Another thing that's bad for you is broken clocks. Anything broken is apparently not good, including at one stage they talk about broken or old brooms. You should get rid of those too because they retain the bad energy in the brushes of the broom. Broken clocks represents bad luck, time being frozen, etc. You're not moving on. So don't have broken clocks in your house. You don't have dead plants because that weakens your energy in your home. It doesn't look nice to have your dead roses in the vase, but these are plants that are growing.
Morticia Adams.
Well, then they're very good. There's a whole range of stuff anyway of this advice from a psychic. Now, this is the sort of mixture of a psychic trying to tap into another area of fringe belief, which is the Feng Shui, and you try and get more bang for your buck by crossing over between different modalities, and you're trying to get sort of as much following as you can. And basically, you say enough silly things, and you'll get in the press, and that's all publicity is good publicity.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more Space Time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.